Welcome to our journey through the history of mathematics. It is a count of two stops. The first one will be in ancient India and the second in Greece. We hope you enjoy the adventure and learn from it. See you at the end and check if it sounds to you.
Welcome to the first part of the exhibition, the mathematics in the ancient India. It is very probable that you have listened or studied very little on the mathematics in this epoch. But do not worry, I am sure that at the end of the exhibition you will be surprised. We have grouped this part of the work in 4 points and we will penetrate on them later. Now, we recommend you to stop the track, to read the geographical and historical frame, and when you are prepared, a rather special character will be waiting for you to start guiding by this visit.
Hello, I am Aryabhata. Possibly do not know me, but don't worry, we will talk about me later. The beginnings of the mathematics in the antique India we can locate in 3000 BC minus 2600 BC in the civilization Harappa, though there are mathematicians who postulate that it appeared in the century 7-8 BC, in the Vedic period. Before the century 4 BC, the Hindus had some contact with the Greek world. The march of Alexander the Great on the India took place in this century. On the other hand, the expansion of the Buddhism in China and that of the Arabic world multiplied the points of contact of the India with the exterior. In a beginning it was in use for calculations in the trade, for measuring the earth and for predicting the astronomic events.
As an important mathematician, we can say 3. Aryabhata. He was an Indian mathematician and astronomer, born in Pataliputra, India, in the year 466. He is the oldest writer of algebra, housework, Aryabhayam, according to other authors, Aryabhatiya. It contains a synthesis of the mathematician known in this time, in much of the Greek original studies of geometry and spherical trigonometry are carried out. The first astronomical studies and 30 theories of flat trigonometry, algebra, and arithmetics are listed. Brahmagupta, he worked as a mathematician as well as an astronomer in India. He set rules for arithmetic with negative numbers and was the first to define and used zero for calculations. The formula of Brahmagupta, which allows to find the area of any quadrilateral given the length of the sides and sum of the angles, bears his name. Bhaskara II, also known as Bhaskara Sahara, was an Indian mathematician and astronomer, known for being the creator of the quadratic and resolvent formula.
Undoubtedly, the mathematics in the ancient India contribute innovations. They modernized the mathematics and the conception that was had of them. We emphasize a series of fundamental contributions. The negative numbers used and belief in the zero. There owes to them the transcendental invention of the positional notation using the number zero as a void value. Now then, what is the positional notation? It is a system of numeration in which every digit possesses a value that depends on its relative position, which is determined by the base, which is the number of necessary digits to create any number. An example of positional numerations is the habitually secondant decimal system based on 10. There will be needed 10 different digits which will have to be constitutive of a symbol 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Egyptians, Greeks, and Romans, though they were using a decimal system, it neither was positional nor was possessing the zero, which was transmitted to Great West later for the Arabs across the medieval Spain and Italy. The multiple practical and theoretical advantages of the system of positional notation with zero, developed by the Hindus, gave the definite impulse to the whole later development of the mathematics.
They were applying the geometry for the construction of religious buildings. This remained reflected in the Sulba Sutras, texts that indicate the rules and procedures in the construction of altars. It was the perfection of the altars, the one that would give them the favor of the gods. As curiosity, the Sulva Sutras do not contain demonstrations, only rules of how they have to be constructed, perfectly symmetrical. In addition, in these texts, a form appears for the theorem of Pythagoras, for comparison of sides. In the photo, we can see a plane of an altar in the shape of falcon, construction with 7 squares and way. 4 form the body of the falcon, 3 were used for both wings and the tail. Finally, every wing was getting longer, with the 5th one of a square and the tail with the 10th one of the same square. Each of these squares took a purusa at every side, unit of equivalent measure at the height of a man with the elevated arms. Also, apart from these 2 innovations that we have just mentioned, there are other 3 that also must be outstanding. They accepted like valid the rational numbers. They penetrated into the often rule of resolution of linear and quadratic equations. There are archaeological evidences that indicate that the Hindus were using system of base numeration octal and had one value brought near for number p. We empathize the manuscript Bakshali as curiosity, text that contains the most ancient record of the number 0. It is composed by 70 pages of bark of birch. Previous investigations had concluded erroneously that the text was dating back to the 8th century. Now it is known that the leaf in which one refers to the 0 dates back to the 3rd century. It is written in Sanskrit. One thinks that it was a practical manual for the merchants who were trading along the route of Idher-Sedates. It includes exercises of arithmetic and something similar to the algebra, besides solutions of linear equations with up to 5 mysteries: the solution of the equation of the 2nd degree, the arithmetical and geometric progressions, the compound series, the quadratic indeterminate equations, and the simultaneous equations. He supposes a discovery of vital importance for the history of the mathematics. The text was found by a peasant in 1881, buried in a field of settlement called Bakshali, in what now it is Pakistan. Later, it was acquired by an academician expert in the Indian culture that took it to the United Kingdom in 1902.
Now, we will pass to the second part of the exhibition, Mathematics in Greece. To start a character pro from this time, I will talk about the situation of mathematics before the Greeks.
Hi, I am Thales of Miletus, one of the most important mathematician in history. Greek was one of the most important period of mathematics. Before I appeared, the Babylonian had introduced the measuring system of time that we have nowadays. They divided the days into 24 hours, hours into 60 minutes, and minutes into 60 seconds. They had already set out problems about daily calculations, contracts and loans of simple and compound interests. In geometry, they knew the triangle's properties, and in algebra problem is up to 4th degree. After them, came the Egyptians, who had already knew the natural numbers and the positive rationals of numerator 1. They also provided the most accurate approximation of pi, 3.16, the one we use nowadays. And they solved equations of 2nd degree and square roots to apply them to the area's problems. Although mathematics were already developed, they presented some difficulties, and its usefulness was only practical, measuring, constructing or counting. And they used the inductive method that consists of arriving at a general conclusion from a set of concrete cases.
However, the Greeks were worried about reflecting on the nature of numbers. For example, Pythagoras thought that the first element of everything, the arche, were the numbers, about the nature of mathematical objects, geometry, etc. They converted mathematics in a rational and structured science with properties that are demonstrated, and in contrast to the previous ones, the Greeks used a deductive method in which a conclusion is reached based on the information that we already had. The contribution of the Greeks to mathematics is the greatest advance of this science in the period between prehistory and the Renaissance. The three classical problems of Greek mathematics are: the first one, the square of the circle. It is the unsolvable mathematical problem of geometry that consists of finding out with only a ruler and a compass a square that has an area that is equal to that of a given circle. The second one is called the duplication of the cube. The problem is to find out by only using a ruler and a compass the side of a cube such that each volume is twice the volume of another cube of a given side. And the last one, the trisection of the angle. The problem is to find out an angle whose measurement is 1/3 of another given angle by only using a ruler and a compass. First period. It is believed that Greek mathematics began with Thales and Pythagoras, who were inspired by the ideas of the Egyptians, the Mesopotamians, and perhaps the Indians. Schools. The Ionian school, founded by Thales of Miletus around 16 before Christ, was the first to begin the scientific study of geometry. The first demonstrations of geometrical theorems are attributed to him by the logical reasoning. Later, it was the Pythagorean school, founded by Pythagoras around 550 after Christ. Numerous mathematical discoveries are attributed to him, among others the demonstration of the well-known Pythagorean theorem. It is said that in a right triangle, the hypotenuse square equals the sum of the squares of the legs. Module. In addition, they develop a first group of 4 mathematical disciplines: arithmetic, music or arithmetic of musical intervals, flat geometry, and spherical geometry. The Pythagorean doctrine held that all the reasons governing the world should be reasons of integers or fractions. These views were opposed by another important Greek school, the Elean school. His criticism took form in the works of Parmenides and the famous Paradox of Zeno. Zeno tried to show that reality is one and invariable, and that of movement is something unreal. Its paradox explored the limits of nature, understood as physics. Here is an example: the argument of the stadium. A runner cannot travel a specific distance in his life, since it breaks down into infinitive successive intervals of length, each of which must be traveled before traveling the next, and without ever going to go through the last, because there is not, since the sequence of intervals is infinity. Movement does not exist. That is, you cannot travel an infinitive space in a finite time. Later, we can mention the first school of Alexandria, whose main representative was Euclid, one of the characters that have most influenced the history of mathematics. His most important work is the treatise De Elements, whose content and structure has been studied in schools and universities until very recently, and it was transcendental in the development of geometry. The Euclidean method comprises, in the first place, a general theory based on axioms, properties that we admit as certain without needing proof because they are evident, the postulates of Euclid. The 5 postulates of Euclid included in his work Elements are: given 2 points, you can draw a line that joins them. Any segment can be extended continuously in any direction. You can draw a circle with center at any point and any radius. All right angles are congruent. If one line intersects 2 other formings on the same side of the second, 2 acute internal angles, those 2 prolonged lines are indefinitely cut from the side where the angles are. For a point outside a line, you can draw a single parallel to the given line. Let's quote Archimedes to finish this brief tour. He was the greatest mathematician of antiquity. It is attribute: the calculation of P by successive approximation, the determination of cylinder and sphere volumes, the quadrature of the segment of the parabola, the use of static movements and center of gravity, etc. These discoveries opened the way to mechanics and integral calculus. From this moment, the Hellenic science began to decline. Second period. After a long interval during which progress is scarce, another fruitful period emerges due to the second school of Alexandria, in which stand out Nicomedes, Ptolemy with his famous system of the world, Diophantus with his great arithmetical investigations, and Pappus, whose work collection is composed of 8 books which contain a series of problems that introduce important geometric notions such as the focus of a parabola, or the guideline of a conic, and the sentence of many theorems, among them the Pappus theorem that relates surface and volumes of solids of revolution with their respective centroids.
This last part of the exhibition has just finished. We remind you that you should return to the back part of the card to listen to the last QR code.